Good morning, chemistry students. This is Mrs. Krumschreider, and we are going to start our Chapter 7, Section 1 notes. This is a review and what is a mole. As an aside, you might want to check out and watch the YouTube videos on my YouTube channel that are Chemistry 1B Chapter 4 notes. There are a total of 3 videos, video 1, video 2, video 3. They are from a couple years ago. Because of us only having 6 weeks, I skipped this, and some of what's in those videos will be helpful as we move forward. I'm going to try to kind of cover that as we move forward, but it might not be a bad idea if you have some time to just take a look and watch those videos. So, just a suggestion. All right, so you'll see that Chapter 7, we start with review. Some of this is review. Hopefully it's a review of stuff that if you haven't learned in chemistry before, that you've learned in some other science class along the way. So we're going to start with a definition of mass. Mass is a measure of the amount of matter an object contains. So the idea is something that is more massive than something else means that it contains more matter than that other object. In terms of the units, the SI, base unit of mass is the kilogram. SI stands for Le Système International des Unités. It's an international system of units that's used by scientists all around the world. It makes communication a lot easier among scientists because everyone knows that they're using the same measure of things, okay? So the unit that's used for mass around the world is the kilogram. Remember, the United States, we're kind of the weirdos out there where we don't use some sort of version of the metric system, okay? Volume. Volume, you've learned about in math class before. It's a measure of the space occupied by a sample of matter. In science, the units used for volume are a liter, which is abbreviated with a capital L. Or in chemistry, we more often use the milliliter, which is a lowercase m, capital L. Okay, so again, I'm guessing you've learned about mass and volume before. Okay, we're going to talk about those things a little bit in reference to the mole. Again, we've talked about what an element is before. Remember, kind of a couple different definitions we have of an element. One of them is that the element is the simplest form of matter that has a unique set of properties okay. Another way that we've talked about an element is that an element cannot be broken down into simpler substances by chemical means. basically what that is saying is the smallest piece that you could break anything down into would be an element, okay? To go smaller than an element, you're going to use something beyond like chemical means. Remember, when we talk about elements, we're talking about the fact that there are 100 plus elements on the periodic table, okay? And again, they're the simplest form of matter with a unique set of properties. We use elements to make compounds. So a compound is a substance that contains two or more elements chemically combined in a fixed proportion. Again, by fixed proportion, what we're talking about is that idea that, for example, the compound water is always H2O. It's always two hydrogens to one oxygen, okay? So that's all we're saying basically here is that a particular substance that's a compound, for example, calcium hydroxide, okay, that it's always going to be made up of the same ratio of elements in that compound. For calcium hydroxide, right? Calcium hydroxide, right? It's going to be one carbon or one calcium, two oxygens and two hydrogens always when you encounter the compound calcium hydroxide. So again, that's all we're saying here is a compound's going to be made of two or more elements. They're chemically combined and they're in a fixed proportion, and that proportion stays the same every single time you encounter that compound. It doesn't change. An atom. An atom is the smallest particle of an element that retains or keeps its identity in a chemical reaction. So remember, we've talked before about really you can use the term element and atom interchangeably. Element by definition kind of means you have a whole bunch of the same atoms together, whereas an atom you could be talking about just one single atom. Okay, so element, atom can kind of be used interchangeably. Here we're talking about the atom as that very smallest piece of an element, and it still has all the properties of that element. Okay, so it's that smallest piece. Molecule is a neutral group of atoms joined together by covalent bonds. Remember, our molecule is made of two or more nonmetals because it's a molecular compound. So again, we've talked about if I had a big chunk of molecular compound, the smallest piece I'd be able to chop it up into and still have all the original properties of that molecular compound. That smallest piece would be a molecule, okay? So atom up here, right, is kind of that smallest piece of an element. A molecule is the smallest piece of a molecular compound. Remember, we know something's a molecular compound because it's made of two nonmetals. Remember to write the formula for molecular compounds. Our prefixes become subscripts, okay? An ion is an atom or group of atoms that has a positive or negative charge. Remember, these ions have some special names. The cation is the ion with the positive charge. Okay, and an anion is an ion with a negative charge. Those are just a little bit more specific names. You could call either of them an ion or a cation or an anion, or you could just call them an ion. Okay. Remember, to get a positive charge, it's because we have lost electrons. Therefore, we have more protons than electrons. And when we talk about an anion, we have gained electrons. Therefore, we're going to have more electrons than protons. Remember, anions typically are going to be your non-metals. Okay, and cations are going to tend to be your metals. Also, remember, you have 10 polyatomic ions you're supposed to have memorized. You also have some additional polyatomic ions that you might encounter on that helper sheet that you have. Okay. So, again, polyatomic ions fall into an ion because, again, that's when you have that group of atoms that has a charge. A formula unit is the lowest whole number ratio of ions in an ionic compound. Okay, so again, remember, we know it's an ionic compound because it's made of a metal and a nonmetal. Or remember, it has a polyatomic ion. Okay. Again, what we're kind of talking about here with the formula unit is this idea that if I have a big chunk of ionic compound, that smallest piece I can chop it up into and it still has all the properties of that ionic compound. That piece is called a formula unit. Remember, also, formula units overall have no charge. Even though they're made of positively and negatively charged ions, overall those ions combine so that they don't have a charge. All right, factor label method, dimensional analysis. This is not so much a review, and again, we're going to kind of go over this each time we use this throughout the chapter, but this is a technique of problem solving that uses the units that are part of the measurement to help solve the problem. You saw that a little bit when I went over ChemQuest 39, the intro to moles, right? We talked about what unit was in the numerator, and we were treating those units like they were algebraic letters. We wanted them to cross out or cancel out, so we made sure which one was in the denominator, right? It's the same kind of idea as if you have 3AB over A in algebra class, you're going to reduce that because the A is in the top and the bottom to 3B. Okay? But what we're going to do is we're going to set it up like 3AB is like this, and we have 1 over A like this, and we're crossing out those A's. Okay? So again, we'll go over this. This is where if you wanted to take a look at those chapter 4 video notes, it might be helpful because I go through quite a few problems like that in chapter 4. Okay? Conversion factor. This is used for this factor label method. A conversion factor is a ratio of equivalent measurements used to convert or change a quantity from one unit to another. Okay, so equivalent measurements, that's kind of important here. If you think about money, right? Think about money. So you could trick little kids with this, but you're not little kids, so you can't be tricked like this, right? If somebody has 4 quarters in one hand and a dollar bill in the other hand, they have the same amount of money in each hand, even though they have 4 quarters in one hand and a single dollar bill in the other. Right? You can fool little kids that don't understand money because if you ask them which one they want, they're going to choose the 4 quarters thinking they're getting more because there's 4 pieces of money, right? But as an adult, you know that 4 quarters, okay, and a dollar bill, that's the same amount of money either way. Also true within the metric system. So that conversion factor would look like this. You'd have 4 quarters over a dollar. Okay. This is also true within the metric system. So if you tell someone to go walk 1 kilometer and you tell a different person to walk 1,000 meters, right? 1,000 meters is 1 kilometer. Those 2 people are going to walk the same distance, even though you told them to do that walking in 2 different units. These are both examples of conversion factors. And again, they're going to kind of be this part here, okay, that we're going to use in this factor label method or dimensional analysis. All right, moving in then to chapter 7, 7.1, the mole, a measurement of matter. We're going to start with what is a mole, okay? And this is important because chemistry, oops, I'll switch back to my orange here. Chemistry, by the way, orange is my favorite color. Okay. Chemistry is a quantitative science. All we mean by quantitative is it involves numbers and units. Okay. Typically, when you think about biology, you often don't think of biology as much as being a quantitative science. Physics definitely is a quantitative science, okay? So all we mean by quantitative is that in chemistry we use numbers and units quite regularly. And part of the reason we use numbers and units quite regularly in science is because we must be able to measure the amount of matter you have. Okay, so somehow you have to be able to know how much matter do you have. So we're going to talk about this in just a couple of minutes and write some things down, but to kind of get you thinking about that, like think about how do you as a person, okay, how do you know that a small little child contains less matter than you, an adult, does? Right? I mean, you can look at the size and guess based upon the size that because that child is smaller than you, they contain less matter. But you also measure it, right? You take the kid's weight and They have less weight than your weight, so they contain less matter. Okay, so that's kind of what we're going to talk about here. So how can matter be measured? And I want you to kind of start thinking about, like, a good time to think about this is a trip to a grocery store. Maybe not right now when the shelves are rather empty, okay? But think about a trip to the grocery store and the different ways that you purchase things at the grocery store. Okay. One of the ways, we're going to talk about 3 ways that we can measure matter. One of the ways that you can measure matter is that you can count that matter. So think about things that you buy at the grocery store by counting them. Okay. You might count the number of apples you need. Okay. If you think outside the grocery store a little bit, other things that you might count. Maybe the number of files of music that you have on whatever device you use to listen to music. The number of files you have in your Google Drive. Okay, so for count, some examples of kind of everyday examples of counting is that you might count the number of apples. You might count the number of files of music. You might even count the number of people in a classroom. Okay, so counting is definitely one way that we frequently measure the amount of matter that we have. A second way that we often measure the amount of matter that we have is we use mass. Again, this is a great one to think about the grocery store. Think about the things that you buy by mass. Now, in the grocery store, you probably don't call it mass. You probably call it weight. But think about the items that you buy by weight. Maybe some examples would be 5 pounds of potatoes, or 1 pound of candy. Okay, there you buy your meat by mass, right? You pay a certain price per pound for your meat, if you can find some right now at the grocery store. Okay, so again, we have kind of 2 ways so far that we can measure matter. We might count the number of items that we have. We might measure those items by mass. Our third way, okay, is volume. Many of you drive a vehicle, might even have a vehicle of your own. And so I think you might be familiar with measuring matter by volume, right? Think about something that you buy by volume. For example, when you buy gas, right? You pay a certain price per gallon of gas. Right now that price is pretty desirable. The price has dropped a bit. But you also can say that you buy other things by volume. You buy orange juice by volume, right? You might buy a quart or a half a gallon or a gallon. You buy milk that way. Okay, so there are lots and lots of things in the real world that you actually purchase by volume. So kind of what we want to kind of get to is this idea that some units that we use indicate a specific number of items. For example, if you go to the store when they open again and buy a pair of shoes, you are expected to come home with 2 shoes. If you go to the store and buy a pair of shoes and only come home with 1, you're going to be in trouble because a pair means that you've purchased 2. Another example, again, going to the grocery store, you often buy eggs by the dozen. Meaning, when you open up that carton of eggs, you expect there to be 12 eggs. Okay, so we know that dozen is another example of a unit that indicates a specific number. Even have baker's dozens, right? If you go and buy something at a bakery and buy a baker's dozen of donuts, when you open up your bag, you expect there to be 13 donuts because a baker's dozen means 13. So we have some units that indicate a specific number of items, like pair indicating 2 and dozen indicating 12. Well, that kind of brings us to the mole. If you recall from that ChemQuest that you did, ChemQuest 39, the intro to moles, you did some calculations initially where you figured out how many atoms there was in a mole. Okay, you're going to see, you will see that a mole indicates a specific number and we'll talk about that number, I think, tomorrow, or on Monday. Knowing how the count, mass, and volume of an item relate to a common unit allows you to convert among these units. And what you're going to see in chemistry is that this common unit is going to end up being a mole. Okay? So, this says review, but this is going to be kind of a little introduction to the factor label method. Again, as we do problems, I will kind of go over them fairly thoroughly. Okay, I am very particular about the way you choose to solve problems. I know that many of you could answer this question without using factor label method or dimensional analysis. However, for most people, the problems we're going to do throughout Chapter 7 are going to be complicated enough that you won't just be able to put numbers in your calculator without kind of laying it out first. So we're going to talk about how we lay this out. So this problem is saying, assume that 2.0 kilograms of apples is 1 dozen and that each apple has 8 seeds. So these are actually meant to be used as those conversion factors, okay? So what this is saying is 1 kilogram of apples equals 1 dozen. Those are the same amount. And that 1 apple equals 8 seeds. So the question is, how many apple seeds are in 14 kilograms of apples? So this problem is asking us to take 14 kilograms of apples and figure out how many seeds that is. So anytime we do these problems, we're always going to start with our given that's in the problem, which in this one is the 14 kilograms. So we're going to start with 14 kilograms of apples. We're going to convert apples to dozen apples. Okay. So kilogram of apples. Oops, and sorry, this is going to be kilograms. Let me fix that. So this is going to be kilogram of apples. Now I like to go through and fill in all my numbers at the end, but this number is going to be kind of here. Okay, we're going to use that information. So dozen apples is in my numerator, which means it has to go in my denominator. And I think you know something about that, right? You know that 1 dozen apples is 12 apples. Okay, so now unit-wise, I have dozen apples and dozen apples. So I'm in apples, and I need to convert apples to seeds, which is fortunate because I know something about that. I know something about an apple and how many seeds it contains. So apples and apples will cross out, and I'll be left with seeds. So again, that's going to use this information here. So filling in my numbers, 1 kilogram of apples is 1 dozen. 1 dozen apples is 12 apples. And 1 apple has 8 seeds. So now you're able to use your calculator to figure this out. Your calculator tells you that you have 672 seeds. Now, we did talk briefly about significant figures the week of March 9th. Remember, with significant figures, we cannot have more significant figures than our problem has. In this problem back here, this only has 2 significant figures. These we're all going to call definitions. And definitions have unlimited sig figs. So for our answer here, we're limited by this 2 significant figures. So we really can't write this answer as 672 seeds. We need to only have 2 significant figures. 672 would have 3 significant figures. So we really need our answer to say 670 seeds. So our final answer is 670 seeds. So you don't have any homework. Make sure you're caught up in chemistry and maybe your other classes as well. Again, take a look at those chapter 4 videos on YouTube if you'd like, to get a little bit more background information about the factor label method and dimensional analysis. Have a good day. I'll talk to you on Monday.